Yes, today lecture I sent you material before, but I want to explain it because when we faced the lecture on the Google Meet, the attendance was very poor. So we want to look at coordinate geometry. Your knowledge of geometry has beautiful applications. We use it in sciences and in engineering mathematics. And what do you need to know about coordinate geometry? There are three objectives. There are major objectives we need to just emphasize in the lecture today. It's a coordinate system in a plane. When you have a plane, I mean a Cartesian plane, and you want to also know the distance between 2 points in a Cartesian coordinate. You want to know how to get the midpoint, the gradient of a line segment, the equation of a straight line, parallel and perpendicular line, intersection of line, and I will talk briefly on the equation of a circle. Now, let's look at these are just things you can practice yourself in summary of that way. I will not bother myself to explain that. When you look at a coordinate system, it's like you have locations of points in a space. Like in the earth, for example, from the knowledge we know about geography, we are able to locate a point on a space. In fact, that's the beauty of some application of geometry. We see that in most map we use like Google Maps. So a point in a space, and the space we are looking at is a space of coordinate system that has like a rectangular coordinate system. We call it a Cartesian coordinate system, where you have y and you have x. This is an example of a coordinate Cartesian system where you have y, this is your y, this is your x. And the s is, we also call the s the Cartesian, while we call the y the coordinate. Now, I will not bother to explain on the polar equations because I don't so much need that, but it's just that it's in the material I'm using. But let me go to the first one I want to explain. Is the distance between 2 points. What are the 2 points in a line? Let me go back to this. Look at this line. This is an example of a coordinate system. Like, see the way I'm using it. This is x, this is y. You have done that in graph. This is x, this is y. Now you have 2 points. Now the application of coordinate system. The 2 points is A and B. How do I get the distance between A and B? And the distance between A and B is D. And if I know the coordinate of B, what's the coordinate of B? That's S2 and Y2. What I mean is I go down, that's my S2. I go to my Y, that's my Y2. So to locate B, the coordinate is S2, Y2. I go to A, what is the coordinate of my A? S1 and Y1. So I have A. So how do I get this distance? That's my D. So go back to, let me now come up to now say that the distance between 2 points, 2 points S1, Y1, S2, Y2 is the square root SY, and it's S1 minus S2 square plus Y1 minus Y2 square. I don't need to bother to explain that for you, but just know these are example of using a Pythagoras theory. That's this square. That's how we got that. So that's the formula to get the distance between 2 points. Now let's see this example. This is the formula to get the distance between 2 points on a space, on a Cartesian space, on a line rather. This is the 2 points. You want to get the distance between them. This is your S1, Y1, S2, Y2. So when you substitute it, you have the square root of 2. These are 2 points. You want to find the distance between them. This is your S1, Y1, S2, Y2. When you substitute this, you have this. In the same way, you have this also. This is just S1, Y2, S2, no, this S1, Y1, S2, Y2. When you substitute into your formula, you have this. This is just to tell you when you have absolute values. We put it absolute values. In absolute value of this, absolute value of this gives you a positive number. So the distance of this, you have this. That's to find distance between 2 points on the line. Now to get a midpoint, now come back to a line. This is A, you have line A to B. These 2 points, this A and B. The midpoint is M. And how do I know the coordinate of M? I already know the coordinate of X, my B, that is X1, Y1. I know the coordinate of my A, S2, Y2. But I want to know the coordinate. What would be my M? So it's just a midpoint. When you say midpoint, it means this M is dividing A and dividing this line. So if I get this, I can put it down like this. That gives me the coordinate of this and the coordinate of this at this point. Now I will not even bother to begin to explain to you the proof of it. But what you just know is that the midpoint of the line segment for X to get that M is S1 plus S2 divided by 2. Y1 plus Y2 divided by 2. That's the formula to get the midpoint. That's to say that the coordinate of this is this one, S1 plus S2 divided by 2. To get the coordinate of Y here is Y1 plus Y1 divided by 2. So this is just the simple way it is being gotten. You have, what this is saying is that you have this coordinate of this for, okay, I pick this Y, this is my Y, and this one over this divided by 2. So I'm going to have Y1. That's how I have Y1 plus Y2. But don't get yourself so, it's because you have to make this 1 over 1. So that's how it is important. Now, in a case you now have that midpoint we got is that it divides it equally. But when you start dividing, sometimes you now have to have a situation where it's being divided to a ratio. Assuming this is A, this is your B. This is A, this is B. Then with the coordinate. Now M want to now divide this line into a ratio. Ratio mu to lambda. Ratio mu to lambda. Having gotten that, what you just do is that you are going to have this formula. I will not bother it. You don't need to bother how to prove it, but just know that it's the intersecting theory. We call it intersecting theory. When M is being divided into a ratio of mu and lambda. That mu can be 1, lambda can be 2. But just know that this is the formula you are using to divide when it divides adjacent to both points. Now, there's another thing you need to know is if you go back to this, let's go, sorry, my slide. If you come to yes, I think okay, let's move with it. Now, I can see here that I have this. So now the slope which is the slope of the line, which is the gradient, it is AC over BC. So that is the slope of my gradient. That's this rising and running. So I can say that the gradient of the line or the slope of the line is y2 minus y1 over s2 minus f1. So there are some things and I think when you talk about slope of a line, when the slope moves upward from the right to the left, what is telling you that y increases as s increases. Such slope is positive. But when the slope is moving downward, we are saying that y decreases as s increases. Such gradient is negative. Now let's look at some example on that. You want to find, this is the formula to get the midpoint. Now you want to apply it to these 2 points, 0, 1, 1. Find the midpoint. This is S1, Y2. S1, S2, Y1, Y2. Applying this formula of getting the midpoint of a line segment, you have 1 over 2, 1 over 2. Now, the same way also you apply it here. The same way you apply it, you want to find the midpoint of this. The same way you apply it here, you get that. Now, the gradient of the line of a segment joining these 2 points, that's the gradient of the slope of the line. This is the formula. Now, given these 2-point coordinates 0, s1, y1, 0, s2, 1, y1, y2, 1, find the gradient. You apply this formula, y1 minus y2 over s2 minus s1. That's the gradient of the line. You have 1. In the same way also you have these 2 points, this point 1, s1, sy1, s2, y2. So when you apply your gradient here, you are going to see something from this gradient. You see that your denominator is 0. And this tells you something, that this equation, from your knowledge of elementary mathematics, it tells you that this is not defined. So this is telling you that the s coordinates of the 2 points are the same. So gradient, we call it infinite gradient. It is vertical. You can do that when you plot on yourself. Just go back and use your plotting that figure. You will see that the line is vertical. When you say it's vertical, it's vertical, vertical, horizontal. So it means on the x-axis, the points are the same, as if I have a point like this and it's straight like this. So on the x-axis, the points are the same. And some type of gradient, we call it infinite gradient. When you apply that between these 2 points, the gradient of this is minus 7 over 3. The same way you apply it here, for gradient, you have 2. Now, equation of a straight line. Now, we already know what is the gradient of a straight line. That's segment AB. We know that, we have just done that. Now, look at a straight line. You now have if you have a 2 point, that's point P, S, that's S, 1 on the line. The gradient is given by this. Now, then what will now be the equation? This is the equation. You see that this, we write it this way, or we write it this way. So I can decide to say y minus y1 equals to m, the gradient, into s minus s1. This is the formula of the equation of a straight line at point x, p, s, 1. Now, when you have your gradient and your gradient intersect, okay, I need to also say, this is a general form of the equation of a line. Y is equals to ms plus c. This is the general equation of the general form of the equation of a line. What is your c? You need to ask me, what is your c? Your m is the gradient of the line. Your c is the intercept of the line on the y-axis. This is an example of this. The c is where the line intersects the y-axis. That's it. And I must also tell you that from the formula of gradient, the gradient of a curve is also the same as tan theta. The gradient of a curve is the same thing as tan theta. And so that's why in horizontal line, the equation, that's y is equal to c, is constant. So that's why we say the gradient is 0. On the vertical line, we have that's vertical line parallel to the y-axis. We'll see there that s is equal to c. Now let's apply this. This is just a coefficient of applying coefficient on the equation of a line. Now I think let me explain the equation of a line passing through 2 points. You see this one is passing through 2 points. This one will give you, this is the way we get this. Is this equal to this? This equal to this? This equal to this? Or this equal to this? But it's passing through 2 points. Now, having known the gradient, m is your gradient, and you can choose either of these points, either S1 or you pick S2. If it's S2, it goes like this. This with this, this with this. I think we will explain it when we look at an example. To be clearer with an example, let's see this one. Let's look at this example. This m. Okay, this coordinate, this S1. This is a coordinate S1, Y1, 0, S2. Okay, let's see problem 1. S2 and Y2 is 1, 1. So the gradient of this is m. You can use your idea of gradient, you know that this is m. So, but you want to find the equation of this line. Already you know your S1, go back to this, your formula. You are going to use, you are using this, and you are using this. You are using this, you are using this. So when you substitute it, you have y is equal to s. This result also, in this place, m is infinite. Okay, now you have two coordinates. This is this and this. And when you get your gradient, you discover the gradient of this gives you to infinity. So such solutions are not defined. But look at 3. These are the 2 points. This point 1, point 2. The gradient is minus 7 over 3. Find the equation. Already you know the gradient is this. You know your you know your S1 and you know your Y1. You substitute it. Come back to this your equation. You know your Y1 and you know your S1. So here we are taking this as S1, Y1. You can as well decide to take this. Depends on, we took care from this problem. This is S1, this is Y1. So when you substitute it, you have this. This is the gradient. This is the gradient. This is the equation of the line. Now this is the same way with this. You have the gradient is 2 and the equation of the line. Substitute it into your formula. This is your S1, this is your Y1. So when you substitute it, you have that. Okay, this is a general form of equation of a line where you have y-intercept. I've explained when you have y-intercept, that's s0, that's y. When s is 0, your y-intercept is y is equal to c. And when y is 0, your s becomes minus c over m. Now let's look at a problem. If your m is 2 and your c is 2, the intercept of s will be at minus 2 over 3. Now look at if you have your m here is 3, your c is 2, your y will become this, the intercept of s will become minus 2 over 6 from here. Now look at this equation. Now you now want to find what is your m, what is your c, what is the intercept. What you just do is to open this bracket. When you open this, you are going to see that you try to put it in the form of ms. Where is your ms? You are going to see that your gradient will be minus 2. You rewrite this. When you multiply this, you bring this to this side, bring that to the other side. You have your m to be minus 2 over 3. And your c, this intercept will be 1 over 3. So now, the s-intercept, what is s-intercept? S-intercept means minus c over m. What is your c? Minus of this over m. So this divide this, you get this. So this is your y, okay, like this. What is your c? Minus c over m. That's it. How did I get it? This here simply means I want to get x. It's just saying that y is 0. When y is 0 here, c goes to that side minus c. I make s the subject of formula. That's what you call s-intercept. The same way you do this other one. Let me go further to round up. You have perpendicular and parallel lines. Like you have line 1, line 2. You can see it on the diagram. These lines are parallel lines. And when two lines, line 1 and line 2 are parallel lines, there's a beautiful application in geometry that two parallel lines have the same gradient. The gradient of L1 and L2 are the same because they are parallel lines. When you use your intersection theory, you will prove that when you have this is the gradient of L1, this is the gradient of L2. By your intersection theory, you are going to see that since A, B, and AM are parallel, then you are going to see that L1, L2, they will be having the same gradient because M1 divides this at the same ratio. But when the lines are perpendicular, like this, perpendicular, these are perpendicular lines. These ones are perpendicular lines. Perpendicular lines, the gradients are not equal. Two lines are perpendicular, they don't have the same gradient. But if line 1 and line 2 are perpendicular, their gradient is M1 and M2. So we say M1 times M2 is equal to minus 1. That's when the lines are perpendicular. But when they are parallel, M1 is equal to M2. These are just gradient. I've told you gradient is tan theta. So what this is saying is that if you have two lines and they are perpendicular, the gradient of the two is multiplied by minus 1. That's why we say M1, M2 minus 1. Now let's see this problem. Any line, a line y is this, okay, any line parallel to y that's equal to equation y. This line y equals to 1 minus 3 has the same gradient. M is equals to minus 3. How can we write it? So what you just do is that this line perpendicular to this, you can rewrite this that this is your equation. Go to your formula of equation of a gradient. Y is equals to ms plus c. What is your m? Minus minus 3. Now, to choose C, that's the line that intersect. That will give you through the coordinate -1 and -2. So when you substitute it, the question is not so clear, but this is a coordinate. These are coordinates. Now you now want to find a line that is passing through. What they are saying that any line that is passing through this, the line passing through the coordinate of this minus, I can reframe it, and it's parallel to this. So what I'm saying is that this is the coordinate and this is the line parallel to this equation you want to get. So then when you now substitute it here, and your C becomes minus, your C will be minus. When you substitute here, your C will be -1. So you substitute it here. That's how you have y is equals to -3x -2. Now, don't let that one confuse you so much, because somebody may be asking, how do I get this? It's simple, because if I want to look at this, for example, if y is -1, then my s will be, what will I have? Y is -1. No, that will not give me that. So I think that's just a point. So not just me showing that from that equation, but I know from here, if I have my y, okay, if I have my y to be 2, okay, I think I'm getting that clear. My y to be 2, then my s will be -1. So it just coordinates this thing. I think I go to this other B. Some questions are not well reframing the test note I'm using. But nevertheless, let's look at B. These are two lines passing through this line A through this coordinate, and add the gradient of M. And any line perpendicular to this gradient is 1 minus 1 over M. The gradient is, so first of all, you need the gradient with this its coordinate. You get your gradient to be 2. So any line perpendicular to this will be gradient of -1 over 2. So the equation will now be y -1 over 2 plus c. Now, we want to say that this line is passing through this coordinate. Now, if it's passing through this coordinate, then substitute s to be -1 here, substitute 2 to be here. So you now get your c. These are points is passing through this point. I think similar way to this one. It's passing through this point. So you now substitute it here, you get your C. When you get your C, you now substitute C into this equation. That's how you get this equation. Now, before I round up, because there's the other one, I think I will stop here. But let me just explain. When you have two lines intersecting, their point of intersection, you have two lines that intersect. These are the two lines, this and this. So the point of their intersection is solving the equation simultaneously. These are two lines, and if these lines are not parallel, that means they does not have the same gradient. So they have some intersect. So if two lines are parallel, from what you know in mathematics, we say two parallel lines cannot meet. But if the lines are not parallel, there is somewhere they are going to intersect. So the point they intersect, to get the coordinate of that point, is to solve the two lines simultaneously. You can even see from this, the gradients are different. That's to show that they intersect at this point. You solve the equation simultaneously. The same way you solve this one simultaneously. But look at this line. If the lines are identical, that is coincident, they have the same gradient and the same intercept. So when you solve this equation 3, you are going to see that when the line is identical and they have, it's like a collision, and they intersect at on the line, the equation will have what we call an infinite number of solutions. In fact, these are some beautiful aspects in mathematics, in space science, when you are launching rocket, and your ability to study the gradient so that there will not be collisions. So here you have lines. If the lines are identical, they coincide. What they mean in English, you say there's a coincidence. They have the same gradient. So the same intercept. So when you want to solve this problem, we say the solution. If you solve this simultaneous equation, the solutions, they have infinite solution. We call it has infinite solution. So that's why such equation represent the same line, and then they intersect at some point. There is an infinite number of solution. And so my other lecture, let me not make, I think what I will do is that, I think I say abstract. Okay, let's take this one. I want to take it in another aspect, but let me just take it. Equation of a circle. Under coordinate system, we want to look at, we'll look at circle, we look at ellipse, we look at hyperbola, and we look at parabola. And you know already a circle has a center and it has a radius. But this is a little bit different from what you did in elementary mathematics, but you already know that a circle is a set of Cartesian axes that has a coordinate where the radius is r and the coordinate is a and b. Now, what you just do here is to know from your knowledge of distance, if I draw a circle like this, and I have 2 points on that circle coordinate a and b, and the distance in between them is r. To get the distance from your knowledge, you know, to get the distance between 2 points on a Cartesian system is this on the line. So that's how we got this. So this one will enable us to define the equation. In fact, this is the equation, this is a general form of the equation of a circle. Now, okay, no, this the other aspect, this is the elementary aspect, but this is the main general form of the equation of a circle. Now, how do I know my F? How do I know my G? My F and my G are just what best should I use to describe it for you? I think my F is equals to my minus A. My B is equals to my G is equals to minus B. And my H is equals to A squared plus B squared minus 2A. This is the general, from this you have gotten the equation of a circle. But this is the general equation of a circle where F is minus A. This general equation is expressed in the terms of this, where, you know, if you go back to this note, take time to expand this as an assignment. When you expand this, you will have something like this. And when you now substitute F in place of minus A, G in place of minus B, H in place of A squared plus B squared plus minus Y squared, you will have this. So what I'm saying is that this equation was derived from this. When you open the bracket of this, you have this. So that's how you got the general form of a circle. Now, this is the equation of a circle. This is a circle with center A, B. Center, you already know a center. The coordinate at the center is AB with radius arrow. This is how we got this. Now you want to now apply it here. If your radius center is 0, 0 and the radius is the equation of the circle is will be this. You substitute this 0, 0, you have this. Find the equation of a circle where the center is coordinate 1, 2, the radius is 1, you have this. Find the equation of a circle where the center is -1, the coordinate is -1 and 4, and radius is 3, you have this. Now, find the center and the radius of a circle whose equation is given in this form. Then you have to re-express it. Already, if you go back to this equation, you already know it. This equation, you know that. So what you just do is to, in doing this, I think I've jumped, okay. First of all, you have this equation. Okay, this is the equation you have, and you are asked to find the center and the radius. So what you do is, this is the equation you are given. You arrange it in a form of completing the square, as in x, as in y. If I use this, I'm going to have -1, and here I will have -9 plus. So when I resolve it, I'm going to have s -1 bracket 2 plus y plus 3 brackets to the power of 2 minus 4. What I just did is using completing the square here to resolve this. If I resolve it, I'm going to have, go to your knowledge of completing the square. Here I'm going to have this and this. So this will give me this. That's how I got. If we take this to that side, you are going to have 4. And when you put it in a form, you take your y here, your a, this will be 1, this will be -3. So your radius is 2. So now if you want to also use this formula too, I have another way I could have done it. Is so I could as well apply that other formula. My f is, there are some things I may not be able to. I can as well apply this and still get my answer. But if you use completing the square to open this and separate this, you'll be able to get the center and the radius. These other ones, you don't need them. I don't need them for this course. So today we have just looked at Cartesian system, how to find the gradient, how to find the midpoint, how to find the equation of a line between 2 points, between a point, and how to know the intersect perpendicular lines. We have said that when you have perpendicular lines, the interval of the gradient is -1. That's m1, m2 -1. But when they are parallel line, the gradients are the same. So I hope I will send you the material for this class. Thank you.